right, now you try it. Take a couple breaths in and out. All right, now it's a good idea always to breathe when we're doing these problems, but did you also recognize that as you're breathing, you're also performing a periodic function? See what I did there? So as I'm inhaling, I'm breathing air in, which is producing a positive airflow. And then when I'm exhaling, I'm producing a negative airflow. And because of that, we can model that type of an idea that's happening. So let's put some parameters and some values out of this to get a sense of how we can model some data. So let's look at a basic sine graph. And we're going to use this first part of the sine graph as the part that we're inhaling. And notice the values are positive, so we have a positive velocity of airflow that we're going to describe as our inhale. And then the second part of our period is exhaling. And it's below the graph, so we're going to call that a negative, or it's a negative airflow. Now, the amount of air that I'm breathing in, I can quantify, or it can be quantified, and we're going to call it 0.6 liters per unit, or whatever it, what was it, per 6.6 liters per second is our volume that we're taking in. So let's look at the basic graph that we've used. Y equals A times sine of BX. So do I have enough information here to go ahead and model this particular dynamic of breathing? The one last period I'll give you is that it takes me 5 seconds to inhale and exhale. So that's one period, and that lasts 5 seconds. So I think we have enough information to discover what we have. So let's take our graph, Y. My amplitude, we discovered through the magic of mechanics, we're going to call that 0.6. And now I need to discover what this B value is in this particular graph. And if I remember that the period was defined by 2 pi divided by B, then I can do some reverse engineering here. I have a period, which is 5. So therefore, I created an equation with one unknown, which means it's solvable. B in this case then would equal 2 pi over 5. So now I know what my B value is for this particular equation. So I have 0.6 sine times 2 pi over 5 x. And so there's the model or the expression that described the inhaling and exhaling of this particular exercise.